Hello friends, our today's topic is measurement applications of PIC microcontroller, and in that applications we are discussing the first application is robotic arm position measurement with block diagram and explanation, and after that we move for digital thermometer, its block diagram working and C code for the interfacing of temperature sensor LM35 with PIC16F877 microcontroller. So in measurement applications, first part is robot arm position measurement. So here we consider that a robotic arm for a moment having the angular displacement about 120 degree, so it can move or rotate from 0 degree to 120 degree, and as per shown in the block diagram here, the gear assembly is connected to convert that particular motion, that is 120 degree, into the twice the rotation of an pot which is connected in line with the uh, robotic arm. So here the 2:1 gear ratio is used for that purpose. If we rotate, or if the arm of an robot is rotated by an 120 degree maximum, in that case here the displacement of pot should be twice that actual rotation of the robotic arm. So for 120 it will becomes 240. So according to that we are designing the pot rotation. So selection of pot is based on the required application and the degree of rotation for the robotic arm. So here to detect the position for the various applications of an robot, here we have to use that gear assembly. According to that, after some rotations in the pot, according to that we will observe the rotations in the robotic arm. So this is the basic block diagram for the detection of robotic arm position with the help of pot. Here pot we may use either wire wound register pot or any high wattage register. So as per the requirement of applications and continuous use, wire wound register pot is very useful or efficient for that purpose. So here the pot motion is based on the supply provided from a controller's pin. So here, as we discussed, the robot arm moves, suppose we consider the 0 degree to 120 degree maximum, and the pot will move from 0 degree to 240 degree as the ratio of gear assembly is twice. And based on that, if pot will moves, that is variable terminal of pot rotates from minimum to maximum, and the angular displacement is from 0 to 240 degree, in that case the voltage or potential appears across that variable terminal of an pot, it will varies from minimum to maximum. So as per the need or uh, usefulness or availability of the voltage, here we use the maximum voltage and minimum voltage appeared across the variable terminal of an pot. And if we see, as we discussed, the wire wound pot is used with the range of 1 kilo ohm value, and its range is 270 degree. So in that case, if we consider that the for 270 degree rotation of an pot, and the resistance for per loop is 2.857, in that case the resolution will be 0.2857. so here, as per the change in the degree, here we got the resolution in percentage. So that particular resistance goes on increasing. So according to that, voltage appeared across that variable terminal is also changes. So if we consider the 1 degree change in the pot, so there will be 0.5 degree change in the robotic arm position. So as per the requirement of an user, we have to decide the rotation of pot in degrees, that is variable terminal of pot. So 1 degree, 2 degree. So here we initially analyze that the position of an robotic arm. So as per the position, we have to decide the rotation of an variable terminal of an pot. So here, to detect that particular variable voltage appeared across the pot, PIC16F877 has 10-bit ADC. So its resolution is 2 raised to 10, that is 1024. So 0 to 1023 bits we may vary the total appeared voltage across the ADC input. So here the analog input is applied from the mm, pot, and we can use that voltage to the variation. So as per the requirement, we select any one of the analog input for the uh, detection of robotic arm position, or if we use multiple, then we use the variable or multiple analog inputs for that purpose. And the relation between the pot position and the ADC and robotic arm in degree here mentioned in the table, that is for 0 degree, so no movement. So pot is also at a rest position, that is initial 0, ADC output is 0, and here we use the 10-bit ADC. So binary numbers generated from that ADC as a digital output are also 10. So for 0, all 10 bits are 0, and for maximum, that is for 5 volt ADC output, it will generate all 1, that is all ones from the 10 digit numbers in binary. So 1 1 1 1 1 up to 1. So here we decide the robotic arm, that is if we consider the 0 degree, 10 degree, 120 degree, like that. So here 120 is the we consider maximum, and for that again it will extend to the maximum to the 127.5. So in pot position 0, if we rotate the 10 degree, or our robot arm is rotated by 10 degree, the pot position is rotated doubles, that is twice, so 20 degree. According to that, the output generated across the ADC is also varies. So output of ADC is maximum we consider as a 5 volt output. So maximum rotation is we considered as a 120 for the robotic arm and 240 for the pod position. So for that purpose, here for 240 degree, here the ADC output is 4.7314, and according to that, the bit conversion is also uh, mm, available in the binary number systems, and the maximum is that the 5 volt. So is the maximum. So as we have selected the standard pot of a rotation of 270, that's why here the output of ADC 5 volt is generated across the 270 degree. Instead of that, we use the 240 degree. So we considering only the 0 to 240 degree. So we consider output voltage from 0 to 4.7314 only, and the numbers are also same. So this is the tabular format in which we are able to correlate the actual robot arm motion and the rotation angular displacement in pot, that is variable terminal, according to that respective output provided by ADC and generated binary numbers. After that, we see the next application, that is digital tachometer, thermometer. So in digital thermometer, here the basic temperature sensor used for sensing the temperature is LM35. So LM35 is widely used temperature sensor in home automation systems or some industrial applications which supports or requires the temperature range from minus 55 degrees Celsius to plus 150 uh, degrees Celsius. So except the in military applications for all industrial applications. LM35 temperature sensor is useful or more efficient. So if we consider the pin configuration of LM35 is, it is an 3-pin IC and available in various packages, TO 92, TO 220, CAN package, and also in SMD package is also available for LM35. So 3-pin IC is there. First pin is VCC, middle one is output, and third one is ground. And here also mentioned the supply voltage from 4 volt to 20 volt, and the output is generated from 0 millivolt to uh, maximum it is a 1.5 volt. As we see, the output will change by a 10 millivolt per degree variation in the temperature. That means that by changing 1 degree Celsius, either plus or minus, that is incrementing the temperature or decrementing the temperature, the output of an LM35 temperature sensor changes by 10 millivolts. So it will supports the maximum voltage across the LM35 as an output is 1.5 volts. So it is able to generate or measure the temperature maximum of 1.5 into 10 millivolt. Also 150 degree 150 degrees Celsius is the maximum range measured by a LM35 sensor, and this is most efficient because no further calibration or scaling is required for measuring the temperature with help of this sensor. So this is most efficient temperature sensor. Some features of LM35 are the, here we discuss it will works up to the maximum 35 to 40 degree 35 to 40 volt, and minimum of -2 volt, but it will typically works generally we apply 5 volt supply to LM35 for the working as an input supply, and it will measure the temperature from -55 degrees Celsius to plus 150 degrees Celsius. As we discussed, the change in output by an LM35 is per degree 10 millivolt. So for 1 degree it will changes the output by 10 millivolt. So its accuracy is about plus or minus 0.5 degree Celsius. The drain current is, so draining current is less than 60 microampere, so power dissipation is also less, so low. Also cost of that temperature sensor is also less, and which is useful for the use at various remote locations also. The available packages, as I have already discussed, TO92, TO220, CAN package is also there, metal CAN package is also there, SOIC, that is for SMD package also there, and output voltage measurement formula is V out is equal to 10 millivolt per degree into T. T is nothing but the temperature, available temperature or current temperature. V out means the output voltage provided, which is restricted up to the 1.5 volt. So this is the specifications of LM35. After that, the next part used in digital thermometer is ADC. ADC available in PIC16F877, a microcontroller. So here the type of ADC is successive approximation type of ADC used in PIC16F. So in short, we say that SAR type of ADC used in PIC16F, and it will works with the help of comparator. That is, this comparator we applies a reference signal, variable reference signal, analog reference signal. So according to that, it will compare the value and generates an output. So reference voltage is a variable, and result is stored from the MSB bit. So here 10-bit ADC is there along with the 8 analog inputs, and we are able to generate the analog input signal into digital format with the help of this ADC by 00 to 1024 bits. So if we consider from 0, then 1023. So total 1024 bits are available for conversion of analog signal, that is maximum 5 volt, to the digital 10-bit output. So This is regarding ADC. After that we see the interfacing of temperature sensor with the PIC16F877. So in this circuit diagram, it is shown that temperature sensor is connected as a input to the RF5 pin, that is it consists of an analog input 4, and uh, LCD 16 by 2 LCD is connected to the port D. Either we connect as a 4-bit LCD or 8-bit LCD. Here it is shown that the 4-bit LCD we may connect for 8-bit LCD also, and remaining pins, that is ground pin number 1, pin number 2 connected to the VCC, pin number 3 is contrast adjustment with the help of pot or trimmer. RS enable, both pins are connected at the port D, and RW is connected to the ground as we are writing the contents on the LCD, so no need to make RW is equal to 1. So if we consider the writing operation on LCD, in that case RW should be connected to the ground. So this is related to the interfacing connections or circuit diagram of an LM35 with PIC16F877 microcontroller. After that we see the program or code for the mm, sensing temperature, that is a header file hash include two variables are declared, one is integer and another one is a character, that is temper. So to display the numbers on display, it will consider as a character. So temp and temper, two variables are used. Delay function as usual, as per requirement we have to select the delay with the help of single for loop or two for loop, that is in 1 millisecond or multiple milliseconds delay as per requirement. So read the analog input from ADC, we use the read function, that is read temperature, that is temp. So here analog read, and after that conversion formula is also there. So according to that, the output of an ADC is converted into that particular number, and data conversion function is used for conversion of integer number into the string for a display purpose. So here only that conversion is done in data conversion. In case of display function here, so display function is used to display the temperature on the LCD 16 by 2. So here LCD out means on display first row temperature. After that we read the value from temper and display to that. After that actual displaying the number, here the unit is mentioned, C is the Celsius. So here temperature value numbers and C for the Celsius. In case in the main function here we define the initialization of LCD. So procedure of LCD initialization done with the help of ADC initialization, LCD initialization. So command mode and data mode as per the requirement we use. So if we are seeing that the interfacing of LCD with PIC microcontroller, in that it is specified that the RSRW status of RW pin, RS pin and enable pin. So according to that we initialize the LCD and we send the commands to clear LCD, cursor off, and then data commands to the LCD, that is LCD out, that is digital temperature sensor message, it will display, and after that it will sense, and each time as per requirement we have to select the delay. And for continuous checking the analog inputs, here read temperature is continuously reading the temperature from the analog inputs, and it will apply to the conversion function, and after that it will go for the display function. So reading the analog value, convert it into the uh, string, that is integer to string, and then display. So this process in while loop continuously going on. So as per the variation or change in the analog inputs, that is variation in the temperature, either increment or decrement happens or occurs in the temperature, so sensed by the temperature sensor LM35. According to that, the output voltage of an temperature sensor changes, so that will create the variation or change in the value of temp variable, and according to that, the temp variable value changes, then it will feed it to the data conversion, and then data conversion converts into the string, and then again feed it to the display function, so that it will display the updated value of temperature on the LCD display. So this is regarding the sensing of temperature with the help of LM35 temperature sensor, and display it on the 16 by 2 LCD with by using PIC16F877 microcontroller. So this is regarding the measurement application related to digital thermometer. So thank you for listening and watching the video of interfacing of temperature sensor. Thank you.